Welcome you all to the Spark Research YouTube channel. This is Dr. Vivchandra, Assistant Professor in the Department of ECE. Currently we are running in the Analog and Digital Communication series. So this is another lecture for this unit first. So this is last session for this unit first, analog modulation technique, right? So in our previous session we have already covered the frequency modulation and the types of the frequency modulation. So in this session primarily we are going to focus on the generations of NB, FM, like and demodulation and then the phase modulation. So these are the parts here we are going to talk. Okay. So like how can we generate and demodulate the NB-FM? So the narrowband frequency modulation. So in the previous session we have discussed what is the narrowband frequency modulation. So if you have not visited, I have already dropped the link in the comment section. You may go through that, right? So here narrowband frequency modulations means your the message signals, and you can achieve this narrowband FM using the DSPSC modulator, right? So because this is almost equivalent to the amplitude modulation only, and then if you use the frequency multiplier you can convert narrowband frequency modulation to the wideband, right? And now actually how can we the generate the signals? So this is the brief structure block diagram that has been governed by the minus angstrom. So this is the first one is the direct and here is the indirect. So here this is your message signal, that is m of t, and integration of your m of t means we are going to convert the use the frequency modulation. So if there is no integration means we are talking about the phase modulation, right? So integration and then DSBSC, this is your amplitude modulator only, and then phase shift. Here your carrier signal is here. Using this crystal oscillator you can generate the carrier signal, and Hilbert transform like your phase shift by pi by 2, and finally if you will add you will get the final phase frequency modulations at this point, right? So once we'll get the frequency modulation, then you can use the frequency multiplier as per your requirements, and then you can convert your modulated wave in the using this frequency converter, and finally after amplification you can transmit your signal, right? So this is that. And now detector side, how will you detect? So suppose this is your FM band, and suppose this is the envelope, the using the envelope detector you can detect your message information. So like here is your FM signal, and then d by dt, that is d uh, if this is your FM then d by dt, and then you will get the signal in the FM signal, and then envelope detector you can use, and you will get the actually the message signal, right? So this is how. Now actually now let's see how can we detect. So demodulations for your NBFM, that is narrowband frequency modulation. So we are going to detect, here is a circuit. This circuit is also called Foster Seeley method. So this is this is very well known method, that is Foster Seeley method. So how will it detect? So primary the tank, the circuit consists of the C1 and L1, so and C2 and L2 from the second tank, and both tank circuits are tuned to center frequency of the incoming signal, and chalk L3 is the DC return path for diode rectifiers for D1 and D2 both, and register your R1 R2 are the load registers that are bypassed by C1 and C2 to remove your RF signals. To obtain the different phases, signal connection is made to the primary side of the transformer using a capacitor. This will just use for the Hilbert transform, so that you can have the phase difference by pi by 2. As the carrier moves off to one side of the center frequency and balance condition is destroyed, and one diode contacts more than the other, this results in a voltage across one of the resistor, and being larger than the other, and a resulting voltage at the output, right? So corresponding to the modulation on the incoming signal. So apart from the modulation, the frequency modulation, phase modulation is also being used. So if you remember, this is the message signal and this is the carrier frequency. So there is no much more difference from the frequency modulation. If you remember, now only phase is going to change right here. So phase, like your angle, if it is like suppose if phase like amplitude is very high, then phase may be the higher, and corresponding like that, if it is low, then phase may be the low. So with the varying the phase in your modulated signal, that is in your carrier signal exactly, you can get the modulated signal. So that is called phase modulation or the phase modulated signal, right? So phase modulation can be defined as the process by which changing the phase of the carrier signal in accordance with the instantaneous amplitude of the message signals, right? So mathematically, how can we write? So mathematically, first we have to find out the instantaneous angle, that is your omega ct, that is your carrier frequency, and along with the angle. So this angle, if it is 0, means in frequency modulation mostly we are keeping theta not, this part is 0 only, we are not talking about it, but here we are just stating the frequency, the angle, and we will keep it varying, right? So theta t will be omega ct plus kpmt. So these kpmt belongs to the message signal. So finally your phase modulation will be a cos and then omega ct and this angle. So this angle only will vary according to the message signal. So this is nothing, this is your message signal only, right? Also you can write in a more better manner, like phase modulation voltage is equal to vc sine and then omega ct plus mp cos gas omega t. So if you remember, in frequency modulation it was just integration, like here kfmt and integration, right? Here there is no integration. Why integration over there? Because in that case we are going to change in the frequency, but here we are not changing in the frequency, simply we are changing in the angle. So that is why there is no integration at all in this phase modulation signal. So this difference you should remember. Okay, so now how can we generate the phase modulation from frequency modulation and FM to PM? So here MT and then integration. So the, if you remember the past slide, then it is very easy to get your MT message signal integration and M alpha, your M alpha and that phase modulation. So you will get the frequency modulated signal. Why? Phase modulation, what is the difference? If you will integrate your MT and then phase modulation means FM, and if you have already MT and then differentiation, and then if you are going to the frequency modulation, then it will be phase modulation. Why? Because integration differentiation already you have done with empty, and here you are going to do the integration, right? So differentiation integration will cancel out, and finally you will get simple empty. That is why this is the PM, that is phase modulation only, right? So so this thing only you can remember. So finally this is the conclusion here, like how can we generate from PM to FM signal. So this is your FM signal. Here you can see your omega ct plus and here integration of mt. So you in this manner it will integration, so your carrier wave frequency will vary, right? And sfm will be your kp d by dt and sfm like this one. And similarly generating from fm to pm signals, so this is your pm signal, so there is no integration means pm. Always it will be in angle only, right? Because both are the part of angle modulation itself. Then integration, just you can integrate your pm signal and you will get your fm signals. And pm signal if you have, then integrate and you will get the fm signal. So this is the way to generate the fm signal from PM signal, and here like how you can generate the PM signal from FM signal. So right, so these are the ways to generate the different signals. Okay, thank you for joining the sessions. We'll come with some questions and answer related to the this course analog and communication, which has already been asked in GATE, and also we'll continue to talk about the different units. Thank you.